All right, we've already talked about trapezoids, haven't we? We've already talked about kites, but we're going to get a little bit more down and dirty, okay, and just more specific about trapezoids and kites. So let's draw a trapezoid. That's a good place to start, isn't it? So I will draw one. I'm going to draw a particular kind, though. I'm going to try to, anyway, try to make it as accurate as I can. Yeah, it's not too bad. All right. So what do we know about a trapezoid? Just anything we know so far about a trapezoid. If I told you this was a trapezoid, what would you know about it? What would you know about this side and this side right here? They're parallel. That's right. Okay. So those would be parallel to each other. How many pairs of sides are parallel to each other on a trapezoid? Just one pair. Okay. Exactly one pair. All right. Remember, a parallelogram has what? Two pairs, okay, of parallel sides. That's parallelogram. Okay, so if you only have one pair, that means the other sides are definitely what? Not parallel. You got it? That makes that a trapezoid. Four-sided figure, and you have one pair, exactly one pair of opposite sides parallel to each other. All right? Let's put some letters in here. Call that K and J. Call this one I and this one H. We talked about this. We said the two parallel sides are called the what? No, I think you said it. The bases, right. Okay, so the two parallel sides. So if I ask you to name the bases, which I don't think I'm going to ask you to do on a quiz or a test, but anyway, just so we know, what are the bases of this trapezoid? KJ and HI. Good, okay. What are the other two things called? The legs, okay, the leg. Is that what we called it? Now I forget. Do we call it the sides or the legs? The legs, okay. So these would be the legs of the trapezoid. Bases and legs, okay? I believe we named this angle right here too, this H and I. We gave that a name. What did we call those? Pretty sure we did. This is the angle that's formed with that base right there. And this is the angle formed with that base. So we would call these what? Base angles. In case I didn't say it before, I say a lot of things and I can't remember everything I say, so we'll put it that down. Yeah, they would be. Okay, but we're going to talk about well, these two, H and I, are base angles to this bottom base, HI, okay? And these two up here would be base angles to what? To KJ. So technically, in general, they would be all base angles, but these are base angles to this base, and these are base angles right here and here to this base up here, okay? So it's what they're base angles to, all right? So these would be base angles to HI, base angles to KJ, all right? Now, let's do what we're going to do. There's a theorem that says if this is an isosceles trapezoid, I think we mentioned isosceles trapezoid before. What does that mean? It means the two non-parallel sides, if they are what? If it's isosceles, they must be what to each other? Yeah, congruent to each other or equal to each other. All right? So this would be an isosceles trapezoid. Agreed? All right, so far, nothing new. But here's the new stuff. Here's what we did not learn when we first learned about isosceles trapezoids. We know, we have a theorem that says the base angles of an isosceles trapezoid are congruent to each other. So this is the base angle to this base, HI. What's the other base angle to HI? It would be this one right here, angle I, okay? Now, if this is an isosceles trapezoid, remember, it has to be isosceles for this to work. But if it's an isosceles trapezoid, angle H is going to equal angle I, all right? Because the base angles of an isosceles trapezoid are congruent to each other. So I could say that angle H is equal to angle I, all right? What else do you think might be equal? It's pretty obvious, I think. What do you think? That's it. No, not H. It's J, because they're base angles to the same base, okay? They're base angles to that base KJ. All right, so those two base angles would be equal to each other as well. So I could say what? Angle K is going to equal angle J. All right, that's our first theorem. Remember, this only deals with what kind of a trapezoid? An isosceles trapezoid. Everybody good with that? Yeah, pretty easy. Here's another thing we know about a trapezoid. Well, let's do the opposite. This says if it's an isosceles trapezoid, remember the if P then Q thing? If it's an isosceles trapezoid, then what did we just say? Finish saying. Then the base angles are congruent, okay? So if you know it's an isosceles trapezoid, what if you didn't know it was an isosceles trapezoid? What if they didn't tell you that it was isosceles, but they told you what? That the base angles were equal to each other, okay? So you got a four-sided figure, and this is the information they give you. They tell you that angle H equals angle I, and angle K equals angle J. Then what could you say about that whole entire trapezoid? Yes, because you know that, because you got the parallel symbol here, okay? So if this is parallel, that's parallel. Yes, you do know that's a trapezoid for sure, just by looking at it, okay? So, and you know that the base angles are equal to each other. So what kind of trapezoid is this? Are you guys playing along? I don't think you're playing along. Come on, eyes up here and let's think and talk to me, okay? There's only a handful of you, all right? So let's talk. Let's just shout out stuff, okay? So if these base angles are equal to each other, what kind of trapezoid would this thing be? It would be isosceles. See, there you go. That's much better. Now I know you're alive. All right, everybody with me on that? That's just the converse of it, right? The first one said what? If it's an isosceles trapezoid, then what? The base angles are equal. This one says if you have a trapezoid and the base angles are equal, then it's what? An isosceles trapezoid. Make sense? It's called the converse. We've talked about that before. If you switch the if and the then, right? The P and the Q, remember that? If you switch it, that's called the converse. So the statement itself is true and the converse is also true. All right, let's do another one. But this time we're not going to talk about the angles. So let's get rid of that, this, and this. And what we're going to do, you've done this before, we're going to talk about diagonals. Now we have not talked about the diagonals on a trapezoid, have we? We have talked about diagonals of a parallelogram. Do you remember what the diagonals of a parallelogram do? They bisect what? How do we say it? A lot easier, cleaner than that. They bisect each other. Okay? They bisect each other. That's a parallelogram. Do I have a parallelogram here? No. So do the diagonals bisect each other? No, look, that side right there, that little segment is way shorter than that segment. So no, they don't bisect each other because it's not a parallelogram. This is a trapezoid, okay? But there is something that's true about the two diagonals. Take a wild guess. No, good guess though. Now it's not 2/3, okay? That has something to do with what we did before, right? With that, remember circumcenter, orthocenter, and all that kind of stuff. But it's not that. Just the diagonals themselves. What do you think the diagonals? What's that? They're congruent. Exactly right. If it's isosceles, I should make it isosceles. Okay, if it's an isosceles trapezoid, all right, so you got to know that. This doesn't work with like any old trapezoid. It's got to be isosceles, okay? So if it's an isosceles trapezoid, then the diagonals are equal to each other. We got it? All right, so we could write down what? HJ would equal what? IK or KI, doesn't matter really how you write it. All right, so this would be true on an isosceles trapezoid. This would be true on an isosceles trapezoid about the angles. This would be true about the diagonals. Are there any other, well, the other two sides, obviously, KH and JI would be equal to each other because it's isosceles. They told you it was isosceles, so they must be equal to each other as well. All right, enough of that. Let's do an example. All right, let's get rid of all this. And I'm going to change the name of it. We'll just stick, we could keep this, I guess, but we'll just stick with what the example gives us. So we're going to call this ABCD. All right. And it is isosceles trapezoid. I got the two sides marked right there. I got the two parallel sides, which means it's a trapezoid. And these two are equal, means it's an isosceles trapezoid. So here's what they give you. Mine's kind of a mess. Okay, let's just write it down to the side, off to the side. So they tell you that angle ABC is equal to 125 degrees. And they tell you that line segment AC is equal to 7x. That's not degrees because it's a line segment, correct? Line segment BD is 4x plus 12. Oops. All right. And they ask you to find a whole bunch of stuff. All right, so let's write down what they ask you to find. They ask you to find angle BAD. They ask you to find angle ADC. And they ask you to find angle ABD. ABD. So they ask you for these three angles. Actually, they ask you for 5 different angles. So part D, they ask for angle ACD. Part E, angle AED. Man, they ask for a lot of stuff. And then they ask for one thing about the sides. They ask for AC, line segment AC. Everybody good? All right, so now where do we start? Let's change colors first of all. Let's start with, let's put the stuff in that we know. ABC, where is ABC? That's this whole big angle right there. So what's that whole entire yellow angle? It's 125 degrees. And then AC, I tell you what, we won't work with AC and BD yet because that's the very last thing we have to do. I just don't want to clog up my picture until I have to. And that's all they tell you right there, okay? So let's see, BAD. BAD, that's this one right here. Well, first of all, tell me something about this yellow angle and this yellow angle. What's true about them? They're equal, right? Because they're base angles. It's an isosceles triangle, and the base angles are equal to each other. So without any math whatsoever, what's angle BAD? 125 degrees. Everybody see that? Okay. Angle ADC. ADC, that's this one right here. Now, is ADC equal to this big angle A up here? No. Okay, so I put 2 arcs here instead of just one, just to show they're different. So how do I find it? It's the only thing they gave you was this whole thing was 125. That's it, because look, you got parallel lines cut by transversal, right? So they're consecutive interior angles, so they must be supplementary. So what's the math? 180 minus 125, and that gives you what? 55 degrees. We good? You don't see why it's 55? Because you got to carry, you got to borrow, right? You got to borrow to put it here. There's your 5, okay? Because I could tell what you were thinking. All right, ABD. ABD, that's this little one. I think they got to tell you something else. I was going to say, yeah, they do. They do tell you something else, and I didn't write it down up here. I should have. I was like, how in the world can you find that? And they tell you that this little angle down here is 30 degrees. Okay? So you got to know that. So if this angle is 30 degrees, what are you trying to find at ABD? ABD. So I tell you what, let's make it another color. Instead of putting like 3 arcs, 4 arcs, 5 arcs, it's way too much. So I'm just going to change colors. So that angle right there, that's what they tell you. What are you trying to find? ABD, which is this one right here. Tell me something about this angle, this blue one, and this blue one. Remember, parallel lines, right? Cut by a transversal. So this blue angle is what? It's equal to this because they're what? They're not consecutive. They're on opposite sides of that transversal. So they're not consecutive. What's the one? It's a real popular one that we used when we did that stuff. It's not consecutive. They're on different sides of the transversal. So what word did we use for that when they were on opposite sides of the transversal? Alternate. Right. So what are they? Alternate what? Interior angles. Okay. Alternate interior angles. That's a big deal in geometry. Alternate interior angles. So if that's 30 degrees, what's this angle right here? That's also 30 degrees. Do we see that? Okay. What else? ACD. ACD. This angle, oops, almost wrote it in there. I'll put a blue one there as well. I'm trying to think of a reason. Do you see this triangle? Do you see this triangle ADC? Trying to think of a reason. Oh yeah. Look, those diagonals are equal to each other, aren't they? Wait a minute. And let's see, this one. Oh, okay, the angle. Yeah. Oh, no, that's not it. Oh, okay. ADC. Hold up. I'm trying to see a reason. I think these triangles are congruent right here. Well, I know they're congruent to each other, but I'm trying to give you a good reason. There's a side. There's an angle. But I'm trying to show that this angle is equal to this angle. Well, because I didn't write down any explanation. I just wrote down what the answer was to it when I did my notes. If I sat there and tore this apart, I could probably come up with something. Now, these two diagonals, they didn't bisect each other, but this right here will equal that right there. And I know your first question. What's your first question? Well, why is that true? That's a great question because that's what I'm trying to figure out. I don't see it right in front of me. If I took some time and separated these, I might see it. I just don't see it. Do you see why these would be equal? Or these triangles would be congruent? Because ADC and BDC would be congruent to each other. There's a side, right, for both of those. There's an angle, right, because you know that those two are equal. So I got a side and then, oh, there it is. Is it? No. There's a side, there's an angle. See, I don't know. Oh, this is shared, of course, obviously. Oh, why didn't I see that? I knew it was easy. Okay, everybody watch. Look at this. Let's go different color. Let's go green. So look, I've got this side, correct? And I've got this side right here. They're equal to each other. Do you see the two triangles I'm talking about? Okay, this ADC and this BDC, all right? Or BCD, I should say. Anyway, I got that side. I got this angle. Remember, these two angles are equal. Why? Because they're base angles, all right? So I got that angle. And now look, This side right here, put 1, 2, 3 tick marks. This side is shared by this triangle, and it's shared by this triangle. So those two triangles are congruent to each other. Agree? All right, so, well, that doesn't even show why. Okay, so the triangles are congruent. Oh, man. I'm kind of stuck. I thought I was getting there. So those two triangles are congruent. So why is this equal to this? Or why is this angle? Well, I'm kind of stuck. Are you guys trying to figure this out? I'm trying to figure out why these two sides are equal. If these two sides are equal, then these two angles right here are equal. Okay? That's the whole thing I'm trying to do here. Because look at this triangle. If I had this triangle and these two sides were equal, then the opposite angles would be equal. Well, I'll just tell you that they are equal to each other, okay? So this angle will equal this angle. This little side right here will equal this side. And I got to do a little more thinking about it. When I'm put on the spot in front of everybody, I freeze up as well. You probably would too, wouldn't you? So anyway, but this angle and this angle are equal to each other. So what is angle ACD? ACD, this angle right here. That's also 30 degrees. There might be an easier way to figure that out, but I can't see it right in front of me. But anyway, they would be equal. All right, let's keep going. AED. This is E, sorry. I didn't put that in there. So AED. Let's go different color again. What haven't we used? Purple? Which one's purple? This one? That purple? Maybe go a little bit lighter. So AED, right there, I'll just make one arc so we're not doing a bunch of them. You know that they would be equal to each other, correct? So that's what I'm trying to find. I'm trying to find that purple one right there. Well, I know this whole thing is 125, correct? So, and this is 30, so what's that? Oh no, let's do it a better way. Here's a better way. Yeah, forget that. Look at this. If this is 30 and this is 30, that's 60, correct? So what's this angle right here? That'd be 120. Agree? Right? If I got a 30 here, I'm looking at this triangle right here, this EDC. So I've got a 30 and a 30, and then this would be 120. What would this angle right here be then? Now, it wouldn't be 120 because it makes a straight line, right? You got a straight line. 60 and 120 forms a straight line. Agreed? You see that, don't you? Okay. So if that's 120, that's 60. Or you could do it this way. This is, if you look at this triangle and I extend this side, that's an exterior angle. Remember what's true about the exterior angle? It's equal to the sum of the remote interior angles. So watch. All I had to do is just add this 30 and this 30 to get that to be 60. All right. However you do it, you get 60 degrees right there. All right. All right, let's do AC. So we've got all the angles, okay? We pretty much figured out all the angles, all the ones they asked for anyway. So now I want to find AC. What is AC? It's that whole diagonal, all right? Well, what do they tell you about the sides? They kind of tell you AC, don't they? Kind of. Go with this orangey color. All right, so they kind of tell you AC. So what do you know about AC and BD? They're diagonals of an isosceles triangle. So what do we know about them? We know they are equal, right? Is anybody playing along? Seems like some of you guys have just lost me here. So what do we know about the diagonals? They're equal to each other, right? So look, that's one diagonal. That's another diagonal. So what are we going to do to them? Set them equal to each other. That's right. And now we should be able to solve for x. Once we solve for x, then we can find AC. Just multiply it by 7, and you got your answer. So subtract 4x from both sides, you get 3x equals 12. Divide both sides by 3, x is 4. It's not my answer though, is it? How do I find AC? just 7 times 4. So 7 times 4 is 28, and then AC is 28. My biggest problem was trying to figure out why this and this are equal to each other. And I'm going to have to look at it a little closer. It's got to be right in front of me, and I'm just not seeing it. But it sure looks like they would be equal to each other, doesn't it? And that's a terrible reason, okay, especially for a geometry teacher to say, wow, it looks like they are, so they must be. No, that's a terrible reason. I yell at kids all the time. You can't just look at it, but here I am doing it just because I can't figure out why these two are equal. But I will at some point. It'll bug me enough to try to figure it out. But besides this one and this one being equal to each other, everything else should make a little more sense. We good with that? All right. So that's enough. Well, no, we got a little bit more for trapezoids. This one is not an isosceles trapezoid. So I'm going to draw a trapezoid, and I'm going to purposely make it not isosceles. All right. That does not look isosceles. Would you agree? All right. So, but it is a trapezoid, but it's not isosceles. Now, here's what we're going to do. This should be familiar because we did this with a triangle. Well, we kind of did this with a triangle. We use the same word. So watch this. I'm going to put that point right there. Where do you think that point is? I put it in that specific spot. What do you think that is? It's the midpoint. That's right. Okay. So I found the midpoint, and guess what I'm going to do to that midpoint? I'm going to connect them. So that should be something that's familiar to you. What's another thing that we did not all that long ago? Well, I don't know. Maybe it was a chapter ago. I think maybe it's chapter 4. Yeah, because we did that in my CP class. But what do we call that thing on a triangle where we connect the two midpoints to each other? Anybody remember what that's called? Because we're going to call that the same thing here. It connects the midpoints. It's a segment, okay, that connects the midpoints, right? So we call this a mid-segment. So we're going to do that here as well. But this isn't the mid-segment of a triangle. What is it? It's the mid-segment of a trapezoid. I'll just put trap because I ran out of room. All right? So that means that this and this are equal, and this are equal. We okay with that? Thank you. Oh, question? Right, so, but they're equal to each other though, right? That side and that side? No, don't equal 0, no. Look, this side and this side equal each other, correct? So you solve for P, right? And you plug it back in to all 4 of them. So once you get what P is equal to, just plug them into all 4 of them and you got all 4 sides. All right, so what are we saying? All right, we'll call this a base. Remember we called this a base? There's 2 bases and they're 2 different lengths, aren't they? So I can't just call this B and call this B. So I'm going to call this B1. Is that all right? For the first base. I'll call this B2 for the second base. It's not B squared. You're not squaring anything. It's just showing you it's a base. So I use the letter B. They're different bases. So I'll call this B1. I'll call this one B2. And I'll call the mid-segment M. Okay? So since it's a trapezoid, you know that these 2 things are parallel. Remember on a triangle, the mid-segment was parallel to the third side? Well, we don't really have a third side here because we have 4 sides, don't we? All right, so what do you think might be true, though, about this mid-segment compared to these 2 bases? The 2 bases are parallel. What do you think might be true about the mid-segment? It's parallel as well, okay? So that's one thing that we know about this, that all 3 of those now are parallel to each other. You got it? Okay. Now, here's another thing. Do you remember when we did that triangle? Let me just draw a little triangle. Remember we did the mid-segment? We said that that was parallel to this. Then what did we say about the length of the midsegment compared to the length of the third side? 2/3? No. It's half, okay? The midsegment was half of the third side, okay? Now look, this midsegment definitely does not look like it's half of this, does it? All right, this looks almost as long as this base, okay? So it's definitely not half of it, right? This one is definitely not half of this because it's actually bigger than this one. But guess what? The midsegment is equal to half of the sum of the two bases. So if I added up base 1 and base 2, and then I took half of it, that's going to give me the midsegment, the length of the midsegment. All right, that's really important. It's kind of like finding the average. All right, would you agree? If I took two things and I added them up, then divided it by 2, I'm finding the average of those two things. And that's what the midsegment of a trapezoid is. It's the average of the length of the two bases. So that's really important right there. It's similar to a triangle. It's very similar to what we talked about, except there's one just little extra step. All right? I think I'm going to finish with trapezoids today and not get to kites. We'll get to kites on Monday. All right? But I got one example to do, and we might as well just use this one right here. I'm going to get rid of this, get rid of this, get rid of this. Okay, so let's put some stuff in here. They actually flip it kind of upside down, but that's all right. I'll just do it like this. Let's call this length 2r. We'll call this length 4r plus 2, and we'll call this 10. All right? And what I want to do is I want to find all three of these lengths. Let me put some letters that they use on this. Actually, they switch the top and the bottom one. Sorry about that. So it'll look a little different than in the book, but it's good enough. So I want to find PQ, I want to find MN, and I want to find SR. You with me? All right, so what do we know? We know that the midsegment is equal to the average of the two bases. Agreed? So watch how we write this down. So the midsegment, which is 10, equals, what do we do? Whoops. Divided by 2. And then what do? We added up the two what? The two bases. So let's put the two bases. One is 4r plus 2. The other one is 2r. And so now what we're going to do, we set it up. Now what we're going to do is we're going to solve for r. Once we solve for r, then I can just plug them in. Agreed? You understand what I did here? The midsegment, okay, it's that little formula. I erased it, but it was on there earlier. Okay, the midsegment is equal to the sum of the two bases divided by 2. Yeah? All right, let's keep going. We could do a couple things in one step. Let's get rid of the 2. How do I get rid of something that's being divided? Multiply. Let's do this in a different color. All right, so watch. I'm going to get rid of this 2 right here. How do I do that? I multiply by 2. Come over here and multiply by 2. Yeah? So what happens then? These 2's cancel. What do I get here? 20. Let's add up my like terms right here. What like terms do I have? 4r plus 2r, which is 6r plus 2. Don't forget that plus 2. So in one step, I kind of did two things, didn't I? Got rid of the 2, and I added my like terms together. Let's get r by itself. What do? No, not yet. We got to get rid of that 2 first. We've got to subtract the 2, all right, before we divide. All right, so that cancels. What do I get? 18 equals 6r. Divide by 6. Now we can divide. So what's r equal to? 3. Is that my answer? No. They ask you to find the lengths of the two bases. Right? We already know mn, which is 10. All right, so how do I find this right there? 2r. So what's that going to be? It's going to be 6. What's this going to be? 4 times 3, which is 12, plus 2 is 14. Let's see if this middle one actually is the average. Okay? 6 plus 14 is 20, divided by 2 is 10. It does work, doesn't it? Okay? And that's how you would solve for them. It's not too hard, is it? All right, you got to know this little formula thing, though, right there. That's super important. You write it down, do a little bit of algebra, and you're good to go. So I am going to... Oh, I don't have it on my notes. Let me check my... So I said 1 through 12. You may not be able to do all 12 of them, but I want you to get a good start on it. So it's section, what is it, 6.5? Yep. 6.5, numbers 1 through 12. You may not be able to do them, so just do the ones with trapezoids. All right, so look at the homework. Okay, if the ones have to deal with a trapezoid, do those. I don't have the book in front of me, so I don't know which ones deal with trapezoids, which ones deal with kites. But we'll do the kites on Monday, all right? But get the trapezoid. I mean, 1 through 12 already is not that much to do, all right? So it's going to be less than 1 through 12. But it's just go to 6.5, okay? If you just go to 6.5, right, you can find the page number. And then 1 through 8, okay, so 1 through 8 is the trapezoids. We'll add the kite ones to it on Monday, all right? Everybody good? Anybody still awake? Man, you guys are zonking out on me today. What's going on? All right, I didn't get much feedback today. A few of you are watching very intently, which I appreciate, but just a few. Yeah, it's on Facts. You don't go to Facts? Oh, of the book. Yeah. You can do